Okay, so again, if ODE is a linear ODE, it must have three parts, right? First part is y's derivative, okay, nothing in front. And then the second part is y. Okay, it can only be y. It cannot be y squared, no. It cannot be like sine y, no, right? It can only be a very clear y and times a function of x. So this function of x can be whatever function of x. It's like sine x times ex times ln x, whatever. So this x, px can be as complicated as you want, but this y must be just y, okay? And then the right-hand side, also qx, it can be as complicated as you want, but it must be only a function of x. It cannot contain any y, right? Same thing for px, it cannot contain any y inside. So let's see. Let's examine the first one. Y's derivative plus e to the power of x, y is equal to x squared, y squared. Okay? So this part perfect, right? It's good. This part is y times here px is e to the power of x, right? It's good. But here, the right-hand side, I want a qx. But now my right-hand side, I have some y inside. Right? So that's a violation. Right? That doesn't satisfy the definition of linear ODE. So this right-hand side here, it's not a function of x. Right? It's not a function of x. It's a function of x and y. Right? So it's not linear. Okay, so it's not linear. Part B, y plus sine x is equal to x cubed y's derivative. Okay, at the first glance, it doesn't satisfy this definition, but okay, satisfying it or not, you can do some manipulation of the equation. If after the manipulation it satisfies this form, it's also considered linear. Okay, so clearly you want this. So let's first move y's derivative to the left. Okay, so plus y is equal to sine x. So here I want nothing in front of y's derivative, so I divide both sides by negative x cubed. Right, I divide both sides by negative x cubed, I will get this. Right, so now it satisfies the definition. Right, here y's derivative, nothing in front, and y times a function of x, so this part is your px, okay, including the negative sign, because in the definition it's plus px, right? It's plus pxy, so please include the negative sign in front. Okay, and the right-hand side, it looks complicated, but as long as it's a function of x only, it's valid. Okay, so to satisfy the form, so it is linear. Okay. And for part C, do the same thing. Okay, xy's derivative plus ln x minus x squared y is 0. So again, first you move everything about x to the right-hand side. So just xy's derivative minus x squared y is equal to ln x. Then you divide both sides by x. So it's y's derivative minus xy is x negative ln x. Okay, so this part is px, this part is qx. Right? They're both functions of x only, so it is a linear ODE. Okay, it is linear ODE. Okay, so the first one is not, the second and third, they are linear.